Hello everyone. This video illustrates the possibilities for analyzing results in the District Lab H Simulation Studio software. This will be done through a scenario representing the operation of 450 megawatt network during a cold winter night, including an episode of energy storage in the network. To analyze this situation, we will first use the plotter, which allows us to display and compare the temporal evolution of certain variables, chosen from the set of variables calculated by the software. For example, outdoor temperature, a boundary condition influencing consumers' energy demand. The second graph shows the evolution of the flow temperature, which follows a heating curve, and then, from 3 a.m. onwards, a very marked positive temperature increase, ending at around 6 a.m. The upper graph shows the evolution of the power demanded by consumers and the power delivered to them, both of which are combined here, meaning that the network has been operated in compliance with all the demands of the consumers connected to it. This graph also shows the evolution of the total thermal power injected into the network to satisfy this operational scenario. The graph illustrates the huge difference between power demand on the one hand and power to be generated on the other, with energy stored in the network at the start of the temperature step and energy discharge at the time of the morning peak. When properly managed, this phenomenon can be used to increase the efficiency of the generating fleet, thus generating energy and financial savings. The District Lab H software can also be used to view simulation results via a map view. To facilitate the use of this view, the engineer can resort to configuration files or graphical themes, which can be saved and recalled from one session to the next and shared between users. For the example we use here, we have a graphic theme that highlights the propagation of fluid temperature by colorizing the pipes according to the temperature of the fluid in the piping. This map view can be enriched with a number of filters that can be saved and recalled from one session to the next. For example, we've programmed a filter for the mean fluid temperature variable, with a threshold set at 155 degrees Celsius. It is also possible to activate formulas, such as the one used to calculate the average of the filtered sample, and apply it to the variables present in the results files. The time at which the map view is displayed can be set by the user, who can then move through the scenario history and observe the same phenomena in interaction with the programmed filters. For example, at the start of the scenario, none of the pipes has a temperature above 155 degrees Celsius, so the map appears empty. Then the pipes gradually appear as they heat up. This clearly illustrates the rapid spread of fluid in the arteries, which is much slower in narrower distribution pipes of the network. The results in the filter tables can be exported in both CSV and shapefile formats. In this way, each modeling element can be exported to a shapefile layer, ensuring interoperability with GIS-type geomatic software. District Lab H also offers the option of displaying piezometric graphs, enabling you to plot the evolution of variables along a path. In this example, the path we're interested in links two of the network's main power stations, called Potern and Villeneuve. The upper graph shows pressure levels on the forward and return lines respectively. The middle graph shows temperature trends along the same path, and the bottom graph shows influence coefficients at the Potern and Villeneuve power stations, respectively. The dynamic animation of these piezometric graphs enables us to observe the behavior of the network from a different angle. It's interesting to note the presence of a pressure cone, with a fairly well-identified minimum differential pressure, located roughly where the temperature peaks and troughs are observed. This is where the waves from the power plants arrive, and also corresponds to the point where the coefficients of influence between the Potern and Villeneuve generators intersect. This video demonstrates some of the post-processing functions available in the District Lab H Simulation Studio software, which can be very useful in practice, particularly for analyzing the complexity of a multi-producer meshed heating network. Thank you for your attention.